the functional and non-functional requirements for this rate limiting concept, so that we don't miss any of the concepts. So under the functional part, we'll try to ensure that we take care, the number of requests which have been served within a particular time window. So I think it's mentioned as 10 requests per hour, which I feel it's too high, too low. So I'll consider 10 requests per second. So I'll make sure that, our algorithm or the workflow works saying, hey, if there are 10 requests sent in a particular second or in a particular minute by any of the client, then we will try to compute that. And if anything is sent more than that, then we'll try to block that. That is how we will consider this workflow. And if at all there is, whenever the threshold is crossed, like, we have limited, it's only 10 requests to be sent. And if you cross the threshold, then probably we'll send back error message saying, hey, too many connections sent, or we have crossed the message. So a proper error message is also delivered to the customer or to the client level. This is what we'll try to check. And we'll try to also see this works in both local as well as a distributed system in productions where we have multiple clusters being there spread across different zones. We'll try to see that this works across distributed systems, and local also it works pretty well. So these are the two functional requirements which I'll try to cover. On the non-functional part, we'll see, I'm sorry. On the non-functional part, I'll try to see, ensure that the system is highly available and it's safe from all the external attacks. And whenever we are designing this, we'll also take care of the performance into factor. Without any latency, without impacting our user experience, we'll try to take this entire workflow. So these are the two functional and non-functional requirements I'm considering when I'm building this approach. Going on next, primarily, I'll also give you how this rate limit works, a top level overview, how we have defined how it works basically. What we do is we will have an interface where the admin or the owner of the accounts can specify initially what is your rate limit configuration. So you can set the rules. We call them as the rate limit rules. We can set the rules. You can set them in various ways, per account level, domain level, user level. So the various ways, I'll probably show some of the samples down the lane. We can set these rules and store them in the DB. So that is the one part of the activity which can be done. Then whenever the request comes and matches the rules, the counter is being computed. It could be per client, per IP address, or per IP address, per domain address, whatever way it is. There'll be a counter which keeps on, incrementing. So whenever the request comes, the counter increases. So once it reaches the threshold, whatever we have given as a maximum number of hits or request accepted, once we reach that, it starts rejecting. So the counter is being counted basically once the rule is matched. Then, as I said, as it exceeds the threshold, will not be allowed to reach the origin server and the error page. This is how the overview of the rate limiting works across anywhere. We'll see what optimizations we do here and what considerations have taken. Before I start with the system design part, three important things which I'm considering is, how do we configure this rate limiter? As I already explained in the previous slide, do we consider this at an IP level, at a user level, at an account level? No, there are various ways to consider. So where do we configure this? So this is the first point I'll probably take a hit. Next, what is the overall size? Because size matters, the memory computation matters. So what is the size of your system, what you're designing, how it takes? So I'll deep dive into these things when I start getting into the algorithm. And the next thing is, where do you place this on a client level or a server level, or in the middleware? I prefer to be as a middleware. I don't place it as a completely client side or the server side. The best portion I think always is once you move from the load balancer, immediately I have a rate limiting service there. Probably if you want authentication layer to be before, you can have one level of authentication layer before, and then you can have a rate limiting service. So I consider this to be a middleware between client and the server. But these are the three important criteria I'm trying to consider. I'll try to elaborate more on these criteria in my overall explanation. So as I told you, this is the top overview of how the entire workflow works here. So I have a user. Once a request comes in, we generate a unique client identifier. If it is authenticated, then I think the user ID itself can be taken as a unique ID. If not, if it is not authenticated, generally we also do for anonymous request. So we can generate one unique key for them. Could be a timestamp versus IP or something like that. A combination, we can do a hash map and get that unique key. So we first generate a unique key, which is sent to the rate limiting service. Basically, this is one microservice or a central service which acts like a platform service, can be integrated with any of the other services. So I see rate limiting is being used across various use cases. It can be used in blocking the request right away, what we are discussing. It can also be used in mail services where you want to prevent spams. You can also put your rate limiting control over this. So there's various places in the applications where you can use this rate limiting. So we can use this as a centralized service, as a platform service, and we can just give the instructions of integrating with any product, in a easier way. So I'm considering this as a microservice. As I told you, this entire rate limiting depend upon the rules which we are defining. This is the rule service which I'm talking, and we have a service user who can update these rules, and all these rules get stored in the database. The database can be a Mongo or MySQL, whichever tends. But for entire real application, I don't depend on this storage. This is basically kind of a backup. I completely depend upon the caching layer, basically, which basically I use it as Redis. So there's a throttling service which pulls the rules from the DB and updates the cache continuously. Other way, primarily with the recent upgrade we did was that whenever we use this rule service and dump that information into the DB, we first dump in the cache Redis, and then we keep a background job which runs at the background and pulls this data from the cache to the database. So this is also another way which we can use it effectively. So finally, the rules, whatever rules we are updating based on IP or user or domain, whatever is our logic, all these rules gets updated in the cache, and via the throttling rules retriever, using this service, we keep on updating them and pushing them to the rules DB, ensuring that this is in sync with us. So whenever the request comes with a unique key, in form of a unique key, the rate limiter service hits the throttling, the cache DB what we have, where it checks with the rules. If there's a perfect match with the rules, the counter is increased. And if it is not above the threshold, then the request is allowed. And suppose if the particular rule match counter is already there at the threshold, and that means we have already exhausted, and there is no space for again moving, allowing any more requests, then that particular rules gets rejected. Now these rejected rules, we try to do some more operations on top of this, where we uh, throw customer saying, hey, there is a 429 error message show to the customer, or 503 error. Basically, generally we show 429 message to the customer, and these requests which are rejected are dropped into a queue, and we reprocess them. So sometimes there would be a legitimate customers, for some reason their request would have went into a queue. So let's say there's a login activity being done, and he clicks submit, and it just says too many requests. Instead of bringing too many requests, we say process is undergoing. And what we do is those kind of valid requests, we use certain ML machine learning algorithms and understand whether it's a legitimate request or a fraud request. And if it is a legitimate one, after certain time found, we reprocess this again to the rate limit too, so that that gets allowed. If it is completely fraud, we drop the request from the queue. So this is how the overall workflow happens. So overall, the major component I see, there's a one which is the rate limiter service, the microservice, which is the main decision maker for the entire flow. The rule service, which actually has a backend with the DB where it stores all the rules. The throttling service, which basically syncs, it's a kind of a background job, which basically syncs the data between the cache DB and the normal DB, so that if it is all the updated rules are there in the cache, it becomes easy for the rate limiting service to increment or decrement the counter, validate with the rules, etc. So we will also see the importance of the cache here in the rate limiter service down the lane. but this is how the entire workflow happens, right? So going to the next slide.